Hello, geometers. This is Ms. Backfish, and I am talking to you about parabolas. We learned some things about parabolas that we had not known before today, and so you have this assignment. And I just wanted to go back over some of the basics with you so that you could make sure to do really well on this assignment and be totally prepared to kill it tomorrow on parabolas. So let's talk about what we learned. First of all, we learned that in addition to the vertex, which is a special point on a parabola, like right here, we have another special point called the focus. The focus is inside the curve, okay? And the analogy I used was if the vertex is a mama bear, she is wrapping her arms around the baby bear, which is the focus, and he gets her total attention or focus. So the focus is the baby bear in this little story. The focus is always inside the parabola, always. It's curved around the focus. Okay, now the distance from the vertex to the focus has some special meaning. Let me just talk about this real quick, actually. The focus has just x and y coordinates, wherever it is located. Vertex, remember the x and y coordinates we call h and k. So now if I was at the vertex and wanted to go to the focus, the distance I would go would be p. And the sign of P goes with how to get from the vertex to the focus. If I am at the vertex and I go up to get to the focus, P is positive. If I was at the vertex and I was going down to get to the focus, P would be negative. Other than that, though, if we just think of P as just a number and not signs, whatever the value is right here from vertex to focus, however far that is, it's the same distance right here from the vertex to the directrix. The directrix is a line. It's a horizontal line if we're talking about parabolas that open up and down. And horizontal lines always have equation y equals some number. And that's why I put a question mark, is because it could be y equals -2 or y equals 7 or whatever. Wherever it's located, it's that y value. So whatever distance this is, like if this were 3, this would also be 3. But when I'm trying to think about the sign of P, I think about going from the vertex to the focus, so that this would be +3 because I'm going up. The reason I need to know P's sign is because P plugs into the equation. It's like a new special thing in the equation that we didn't know about before. P comes right in here, so that the number out in front of parentheses is 1/4P. If P is positive, that makes the whole thing open up because I'm going up to get from the vertex to the focus. If P is negative, that makes me look something like this. Going from the vertex to the focus, here's the focus, that means I'm going down. So that means the whole parabola opens downward. So if P is positive, this is just another way of saying P is positive. P greater than 0 is P is positive. P less than 0 is a way of saying P is negative. So if P is positive, it opens up. If P is negative, it opens down. And I could just fill into the equation. That's really the only difference between the equation we talked about today and the equation we've been using. H and K are still in there, and they're still the x and y values of the vertex. So let's look at how this fits problem number 1. Problem number 1, my vertex is at 0, 3. So 0, 3 is the H and the K. All right. The focus is 1 unit up from the vertex. Notice it opens upward because the focus is up, which means P is positive. How much? It's +1 because I go up 1 from V to F. So P is +1. That means that part of the equation that says 1/4P, I can plug in a 1 for P and get 1/4 times 1, or just 1/4. So that means my equation is going to start y equals 1/4. Now we can already fill in the rest of it because x minus 0 squared plus k. This is the h and k. I could rewrite that as y equals 1/4 x squared plus 3. I don't have to write x minus 0, in other words. Where would the directrix be on this one? Well, if we went up 1 to get to the focus, we would go down 1 to get to the directrix. So the directrix would be right here at y equals 2. And that's how you do number 1. Now, you'll notice that 1, 2, 3 all seem to open up or down. And we also talked about ones that open left or right today. And it doesn't look like you get to one of those until later. Because if you notice, all of the 1, 2, 3, and 4 start with y equals. Number 5 starts with x equals, and that's what a parabola that opens left and right looks like. If it opens left or right, everything's pretty much in the same place. The focus is still inside the curve. The vertex is still HK. P is still the distance from the vertex to the focus. And if I go to the right, P is positive. If I go to the left, P is negative. Okay? The directrix, don't ever let the parabola cross the directrix. It's like an invisible boundary line. It's like an electrical fence, and the mama bear is standing directly between her cub and the fence. Okay? So this is your invisible boundary line. That's the directrix. It's not horizontal anymore. It's vertical. So now it's an x equals line. Notice the directrix is x equals when the equation is x equals. When the equation is y equals, the directrix is y equals. That's not a coincidence. All right, so the big difference is how the equation works on this one, that you basically trade, flip-flop all the x's and y's, including h and k. The other one started out with y equals. This one starts out x equals. 1 over 4p stays exactly the same. The only difference is if p is positive, that opens right. P is negative, opens left. This time, where it used to say x minus h, it says y minus k. So not just the x and y trade places, but the h and k do also. Here's the original. And here's the new one. X and y trade places, and h and k trade places. The k is inside the parentheses with y, and the h is outside. Okay, so that's what you would use when you're looking at number 5. That 1/12 is the same as 1 over 4p, so you would have to think about 1 over 4p equals 1 over 12. Well, that means that 4p must equal 12. So what do you multiply 4 times to get 12? P is 3. Now, where's the vertex on this one? Well, if you don't have x plus something or x minus something, it means 0. And we don't have any pluses or minuses here or here. Both of these have a vertex at 0, 0. If P is positive 3 and it's opening left and right because it's x equals, positive means to the right. So 1, 2, 3, here's my focus. So there's your vertex and your focus on number 5. As far as the shape of the parabola, I'm okay with just you doing a big U. I don't need you to necessarily plug in lots of points on this. Okay? And then think about where the directrix would be on this one. Now on 7 through 12, you're going to need to graph those. You don't necessarily have to make the most perfect, accurate graph in the world. Really all you need, and like I could do it on graph paper here, but I'm going to do it on plain because I want to point out to you, all you really need to know is whether you want up, down, left, or right to get from vertex to focus and things like that. Like on number 8, the vertex is at 0, 0. The focus is at negative 4, 0. So that's 1, 2, 3, 4. This is my F. So then I have to think about how this shape is going to work if the curve always goes around the F. Here Mama Bear is wrapping her arms around the baby. So here is my parabola. That means the directrix would be over here, 1, 2, 3, 4 over this way. This one opens left and right, so this is going to be an x equals situation. Looking at number 11, I want to give you another example. All of these on 7 through 12, they give you 2 out of 3 of the vertex, focus, and directrix, and you have to use that information to get the rest. On number 11, you have 2, 7. 1, 2, 3, 4, 5, 6, 7 for the focus. And the directrix is at y equals negative 3. Boy, that's a long way away. And I can't zoom out. I guess I'm going to have to write it. Here it is. Y equals -3, and way up here is the focus. All right, the thing you have to remember is focus is the baby cub, right? Directrix is the electric fence. Don't we have somebody trying to get between the baby cub and the electric fence? Yes, the vertex. That's the mama bear. So think about how far apart these are. If this one has a y value of 7, that's +7 up above the x-axis, and this one is a y value of -3, which is 3 below the x-axis. That's a total distance of 10. 7 above plus 3 below, that's 10 units. So really my my vertex has to be right between them, halfway between them. So that means it has to be 5 from either side. So 1, 2, 3, 4, 5. 7 minus 5 is 2. And I could double check. From -3 to 2, is that 5? It is. So here's my vertex. And it's going to do something like that. All right, so go ahead and do your best on this. I know you can get a lot of these things. Think about where the directrix is. Think about where the focus is, that kind of thing. Key thing is to remember, no matter which way it's opening, that you have in a row the directrix, the vertex, and the focus. And these distances are exactly the same. Okay, that's a key thing. All right, enjoy your homework. I know that you'll be thrilled to do it. And do your best and come in tomorrow ready to absolutely kick it on parabolas. See you tomorrow.